Morning, AJ.
Morning.
Good morning, Day. All right, good morning, everyone. I don't know where everyone else is. I didn't know it was skip my class day. I know it's only 9, but it is 9. All right, so today we're going to continue with the normal distribution, but we're specifically talking about z-scores today. If you looked at your mini lesson, it might have been a little bit confusing, but hopefully it's going to start making sense after class today. All right, so let me share my screen. And we'll do a little bit of a warm up first. I do have this on a handout that's going to be your handout for today. So if you want, you can make a copy of it. I will put it in the chat right now. Maybe I can find the chat. There we go. All right, so there's the document with the problem on it. It's the life of Sunshine DVD players is normally distributed with a mean of 4.1 years and a standard deviation of 1.3 years. So if you look on that document that I just gave you, this is number 1. And I have a picture drawn for you. And then it says, draw out the normal distribution, include a title for the normal distribution and a title for your horizontal axis. Be sure to include your units and labels, and then write out your data values along the horizontal axis. So this is what we were doing yesterday, right? Where you label your mean, and then you label all the lines to the right of the mean and to the left of the mean. So try that, and then we'll talk about Thunderbird Thursday, and hopefully everybody else will arrive. when you're all done, type to me in the chat, I don't know, anything, a kooky word, something. Okay, for those of you who are just getting here, make sure you're on time. And there's your document for today. We're doing this warm-up example. All right, how'd you do? You get them all in there? Yeah, nobody typed me anything. I don't know if you're still working or what's happening. All right, so let's talk about this. What did you label this middle line? Ashley, what did you label that middle line?
Honestly, I'm so lost that I was waiting to go over it with you.
Okay, Dom, can you help her out? What did you label that middle line?
4.1.
Very nice. Why 4.1?
Because it's the mean of the data. So the mean
Very nice.
in that middle line.
Good job, Dom. Yep. So the mean is the middle of the normal distribution. So you labeled it 4.1. Okay. What did you write 1 to the right of the mean? Amanda, what did you put right here?
I put 5.4.
Very nice. And how'd you get 5.4?
You just add the standard deviation of 1.3 to the 4.1 to get 5.4.
Excellent. So you write the mean in the middle, and then 1 to the right of the standard deviation, you just add 1 standard deviation, like Amanda said, so just add 1.3 to it. Angelina, what did you get for the next line to the right? Right here.
I'm doing it right now. Okay, 12. Oh wait, 5.4 plus 6.7.
Okay, there you go. Because you just did 5.4 plus 1.3. Excellent. All right. And then one more. Ashley, try to give it a try now that you know what you're doing.
Be 8.
Very nice. All right. And then to the left, instead of adding the standard deviation, we subtract the standard deviation. So what would you get right here, Deshay?
2.8.
Very nice. And then one more to the left. Amari, what'd you get there?
1.5.
Very nice. AJ, what'd you get for this last one?
0.2.
Very nice. All right. Now, the directions told you to do some things. What did it tell you to do that we didn't do yet?
Include units and labels.
Very nice. We need some units and labels. So what would our units be for these numbers down here at the bottom?
Years.
Very nice. Years. And then what else are we missing? We're missing some labels. What does every graph need?
A title.
Very nice. Jende, what would you title this graph?
I guess DVD player, the life.
Okay. And we could be more specific if we wanted to, right? But at least we
Yeah.
have a title now. Excellent. Okay, so this is what we did yesterday, right? We were able to label the mean and label 1, 2, and 3 standard deviations above and 1, 2, and 3 standard deviations below, right? Okay, any questions on this before we keep going, because it's going to get a little bit different. Everybody okay? All right. So a z-score, this is what you did your mini lesson on last night. The empirical rule only applies when a value is exactly 1, 2, or 3 standard deviations away from the mean. So remember how we were doing those percentages yesterday, where we were like 68%, right? 95 and 99.7. But what if we're in between these values? That's where it becomes a little bit harder. So a standard score is also called a z-score, and it's the number of standard deviations a data value is from the mean. And we can plot z-scores on a special normal distribution called the standard normal distribution. And this is the most important part of this page right here, because I know there's a lot of words going on there. The standard normal distribution is a normal distribution that has a population mean 0 and a standard deviation of 1. Yes? So what it's doing is it's taking all the different values that you have when your mean is, what did we just have, 4.1, and your standard deviation is 1.3, and it's adjusting them to make a standard. Okay, so then we can compare things easily. So if you took like the ACT versus the SAT, it's hard to compare those scores unless we put them on the same scale. And that's what this standard normal curve does. Okay. So a z-score is specifically how far from the mean things are. So if it says a z is 0, that means it's exactly the same as the mean. Okay. If the z-score is positive, it's above the mean. If the z-score is negative, it's below the mean. And here's the formula to find the z-score. So look what you have to do. you have to take the data value, subtract the mean from it, and divide it by the standard deviation. And that will give you the z-score. Okay? So if we look at our picture that we just had, our Life of Sunshine DVD players, we had these scores already. These were our data values. Those were in years. Now I added these z-scores. And let's think about how that makes sense. Let's look at the connection between these two right here. Remember, a z-score is found by taking the x value minus the mean and dividing by the standard deviation. So if we go back to our problem, our x value right here is 4.1. Well, they told us our mean was 4.1, right? And then they told us our standard deviation was 1.3. When you do this, 4.1 minus 4.1, you get 0. And 0 divided by 1.3 is going to be 0. So that's why this x value of 4.1 has a z-score of 0. You could do the same, like if we go way up here with 8, just to make sure we're understanding what's happening, we could find our z-score of 8. We would do 8 minus 4.1 divided by 1.3. And you can try that on your calculators and make sure you're careful if you need parentheses or whatever. So if I do that on my Desmos calculator, if I do 8 minus 4.1, if I'm not careful, if I just do my division sign right here, that's not what I want to do. Okay, so be careful. Make sure you have parentheses, make sure you have something. So I'm going to start with parentheses, and I'm going to say 8 minus 4.1. I'm going to end my parentheses. That tells it it's my numerator. Now I'm going to divide by 1.3. And do you see my answer is 3? So be careful on your calculators. Make sure you're putting in parentheses or you're doing it in 2 steps so you don't get the wrong answer. Any questions on that? Okay, so z-scores are helpful because then we can compare things easier. And we can find the exact value of where things are, because now I can find a z-score of a data point that doesn't fall on one of these lines, right? I can find a z-score of any value I want, and that's going to tell me what percent is below that, what percent is above that, okay, where that's located. That's very helpful. Okay, so now if we look at this, this is on that worksheet that you have. If you don't have the worksheet yet, I'll put it in the chat again. It says, how long does a DVD player last if the z-score is -2? So get your answer ready in the chat. How long does a DVD player last if the z-score is -2? So you're just reading this graph, whether the graph you made or the graph that's on my screen. Everybody have it ready in the chat? All right. 3, 2, 1, go. I love that so many of you put units on there. Good job. So if we looked at our picture, a z-score of, a z-score of -2 is right here. And that would be a value, an x value of 1.5. which is 1.5 years. Questions on that? All right, see if you can answer these three for sure. I know you can. And then this one might be a little bit harder. So think about that one, but definitely answer how long do 68% of the DVD players last? How long do 95% of the DVD players last? How long do 99.7% of the DVD players last? And then see if you can answer that last question. I'm going to give you a couple minutes for that. When you're done, type to me in the chat what you want for lunch. I'm hungry.
Oh, my bad.
Okay, some of you aren't typing for me. I see 2 lunch places and I got a question, so that's good. So Amari, are you done? Valerie, Aaron, AJ, Malachi, Olivia, Deshay, Angelina? I didn't hear from any of you. Oh, there we go. Now I see. Now I got some. What's up with so many people wanting chicken? Wanting some Chick-fil-A. All right, I haven't been to Chick-fil-A in a long time. All right, so let's talk through these. Let's make sense of what this is saying. This is telling you, remember our 68% came from plus or minus 1 standard deviation, right? The empirical rule is plus or minus 1 standard deviation. So there's minus 1 standard deviation, there's plus 1 standard deviation. So what this is telling you is that 68% of the Sunshine DVD players last between 2.8 and 5.4 years. Does that make sense? That's what it's saying. So if you buy a Sunshine DVD player, you could expect it to last, most people, right, over 50% of the people, 68% of the people, it should last almost 3 years, all the way up to 5.5 years. Does that make sense of what it's telling you? Okay, so on the next one, I'm hoping you said it was between 1.5 years and 6.7 years. Now, I want you to think about this, right? Because if it's you buying the Sunshine DVD player, how likely is it that you get the 1.5 year one and you're mad, right? Compared to somebody else who buys it and theirs lasts almost 7 years. But what this is telling us is just 95% of the Sunshine DVD players should last between 1.5 years and 6.7 years. So if you buy a Sunshine DVD player and it only lasts 6 months, it's a rare occurrence, right? Because 95% of the time, it would last at least 1.5 years. Does that help you guys understand what this is telling us better? Okay, and this last one, well, this is silly, right? Between 0.2 years and 8 years. Well, this is where your luck might come in, right? Are you unlucky? Are you going to get the one that lasts 0.2 years? Or are you going to get the one that lasts 8 years? Or somewhere in between. But notice that most people, it lasts almost 3 years and less than 5.5 years. Now, on this one, you might not have remembered the z-score formula. It was z equals x minus the mean divided by the standard deviation. So when it says a DVD player that lasts 6 years, what value is that? Is that our z? Is that our x? Is that our mean? Or is that our standard deviation?
It's the X.
Very nice. It's the x. So when you plug in, you say 6 minus our mean was 4.1 divided by our standard deviation. You might have had to calculate it by subtracting these two values, or you could remember it from the previous example. It was 1.3. And for an answer, Valerie says she got 1.46. Did anyone else get 1.46? Yeah, I saw Aaron shaking his head. Angelina, nice. Malachi, good. So these scores are connected to the original scores, but it's going to show us where these things are. Now, I'm going to put in the chat a Z table. You might have seen this last night on your mini lesson. On the test, I'll have a Z table right there that you can look at. So you won't have to have one accessible. It'll be in the question. Okay. So this is the Z table, and I have one on the next slide so you can see it. So this right here, the very bottom, it says, okay, we got our Z score to be 1.4615. So what does this mean, this area mean? Remember how we were calculating what percent is below this, what percent is above this on our examples yesterday when we were doing the last four I, J, K, and L? Do you remember those? Where we said what percent has a weight greater than 9.27? Remember those from yesterday? That's what this Z table is doing. So if you look at a Z table, this is what it kind of looks like. If you read this very top, it says, this is area under the standard normal curve. In other words, these are percentages, believe it or not, because all of the area under the curve would be one whole, right? Or 100%. Okay. So if we look at a Z-score of 0, do you see how the area, it says 0.5000? What percent is that?
Is it 50?
It is 50%. It is 50%, right? Because remember how you change a decimal to a percent, you multiply by 100, which shifts the place value 2 to the right. So that's 50%. Now what that tells you is in a normal curve that looks like this, right here at the mean, there's 50% of your data to the left under the curve. We already knew that, right? That's why I picked that value, so you would recognize that. So if we're using the one we just got in our problem, remember we got 1.46. But if you look at 1.46, it's not on this. I have my choice. I have 1.4 or I have 1.5. Which value do you think you should use and why?
1.5
Yeah, how come?
around it.
Very nice. Since it's closer to 1.5 than it is to 1.4, we're going to use this value. So do you notice that that says 0.9332? If we make that a percent, that means it's at 93.32%. So if we go back to our picture right here, this is 93.32%. So if we have a score of 1.5 right here, we have lasted longer than 93% of the DVD players, right? 93% of the DVD players lasted less than this. That's what this is showing you. So the area to the left would be 93.32%. How would I find the area to the right? How would I find what percent or the area to the right? Any ideas?
Would you just subtract it from 100?
Yeah. Very nice, Malachi. So I would take 100 minus that 93.32. Or if you were looking at this original value, you could do 1 minus 0.9332. Either way, right? What do you get when you subtract those?
$6.68.
Very nice. So 6.68%. So 6.68% of Sunshine DVD players would last more than 6 years. Okay, that's what it's telling you. So do you see how this stuff on this table is relating to what we talked about yesterday, but it's giving those in-between values instead of right at 1, 2, 3 standard deviations above or 1, 2, 3 standard deviations below. It's going to give you all those in-between scores. Now, this Z table only goes to 1 decimal place for most of them. When you get real small, it goes to 2 decimal places, as you can see right here. But my point is, if you looked up Z tables on the internet, you can have more specific Z tables than this. But this is the one we're going to use for this class. You can also find Z scores here on your calculator. Okay? Just so you know. All right. So before we move on here, questions on what we've just talked about, because I know that was a lot.
Do normal rounding rules apply there? So if it'd be 1.45, you would still stick with the 1.5?
Yep,
Got it. Okay.
exactly. Good question. All right, so this is just more of the same. It's saying, okay, now you have a data set consisting of scores on a standardized test that were normally distributed. The mean in this case is 510, and the standard deviation is 95. And it says, what percentage of the students scored less than 650 on the test? Well, when we ask that question, notice anywhere in here, it doesn't say calculate a Z-score. It just asks you a question that says, what percentage of students scored less than 650 on the test? So you have to figure out that given these clues, when it says normally distributed, and it gives you the mean and the standard deviation, and then it asks you a question about percentages, it's going to want this Z table being used, okay? So, and it says less than 650 on the test. Now, you could write in all your values right here. But now that we know this Z-score formula, we don't have to, and we can jump to just the table after we find our Z-score. So if we take our X value of 650, and subtract off 510, because that's the mean, and divide by 95, interesting that we get a Z-score of 1.47. That was very close to our Z-score on the last problem. That can happen because remember, we're standardizing the scores. So this Z-score of 1.47 means that it's 1.47 standard deviations above the mean. So a score of 650 is pretty good, right? So then we're going to go to our table, and we're going to, here's our 1.47. If we look at our table, we're finding all the area under the curve. So this would be all the people who scored less than 650 on the test. So we go to our Z-score again. We're going to use that same one of 1.5, and we get that percentage of 93.32. So So we can say that approximately 93.32% of all test scores were less than 650. Now, do you remember taking tests and they told you your percentile? You ever remember taking a test and you got the results back, like if you did AZ Merit or something like that, and they said you were in the 93rd percentile? You remember hearing any of those words? That's what this is right here. So a person, if you scored 650 on this test, you scored better than 93% of the students who took the test. Does that help you make sense of it? Okay. Now, this is on your worksheet. So, and it's saying the area to the left of X is 0.123. What's the area to the right? So the area to the left is 0.123. What's the area to the right? How would you find that? We don't have to look at a table. We just have to use what they gave us.
Could it be 1?
What do we do with the 1?
Subtract?
Yeah, so we go 1 minus 0.123. If you look at the top of your Z table, it tells you, note all values are the area to the left of the specified Z score. The area to the right is 1 minus the area to the left. So if it tells you this is the area to the left, to find the area to the right, you do 1 minus that value. If it tells you the area to the right and it wants the area to the left, you still subtract from 1. So find those two values. And get them ready in the chat. Both of them. All right, you have both of those ready? Type them both in the chat. And then we'll do 3, 2, 1, go. All right. So let's make sense of this. If we do 1 minus 0.123, that is 0.877. What that means is, by the way, 0.123 would be about here. It would definitely be below the mean because it's basically saying the area to the left is only like 12.3%. So that's this part right here. And if we want the area to the right, that's going to be like 87.7%, right? So that's what this is saying here. The area to the right is in blue, which is 87.7%. The area to the left was our original value of 0.123%. So on our second one, we had a little bit of confusion. So notice that the area to the right is 0.54. So remember, if it was right here, the area to the right is 50, the area to the left is 50. So if we want the area to the right to be a little bit bigger, it would be about right here. And I'm just rough estimating. So it's saying the area to the right is 0.543, which is about 54.3%. So if we're finding the area to the left, it's not going to be negative. Don't be tricked because it still has to be a positive because it's a percentage. So when we do 1 minus 0.543 and we get that 0.457, we're saying that the area to the left is just under 50%, right? About 45.7%. Now, this was not in context. This was just random numbers that I'm giving you, right? But sometimes more does that to you, just gives you random things. I just want you to see how they're connected to the whole of 1 or 100%. All right. So what I want you to do right now is read through this. You can draw your normal curve. This should be on your paper. So this says it's normally distributed. The mean is 84.6. The standard deviation is 19.1. Draw the normal curve, shading the solution region. So notice on your worksheet, you have different pictures for each one of these. Did you notice that? I hope. So you'll draw a separate normal curve for each one of those so you can shade. Now you don't have to label every single one, but I would definitely label this. So first label these, label them with your regular numbers and your z-scores. And then we'll do the first one together and then you can do the rest of them. So right now, label these with your x values and your z values. Okay, and then we'll go over that. All right, do you have them all labeled? You didn't do all of the problems yet, but at least you have them all labeled. Perfect. So someone who's a little unsure, pick either the X values or the Z scores to tell me to label all of these lines. And then just read them all to me from left to right. You guys are killing me today. I don't know what's going on. Some of you, I'm worried because there's a test coming up and I'm not sure you know what's happening. Some of you are like, I just want to sleep today. Well, there's not very many of you. So somebody's going to have to step it up.
Did you want just the for both of them, for the Z and the X? Or
First, just give me one of them. Right?
Okay.
First, just give me one of them.
Yeah, so for the right down the middle, I had 84.6. And then to the right of that, 103.7. And then 122.8. And 141.9.
Perfect. That's great, Aaron. You can stop there. We'll make someone else answer. So, Ashley, I'm ready now. Fill in the ones to the left.
Okay, one sec. So where we started in the middle with 84.6, below that would be 65.5. And then 46.4, and then 27.3.
Perfect. Excellent. Any questions on those values? Those were the hard ones. Ashley and Aaron did a great job. The Z scores are the easy ones. Who wants to do the Z scores?
-3, -2, -1, 0, 1, 2, and 3.
Nice. See, volunteer for the easy ones, right? I get it. That's awesome. Good. And that'll be the same on every single normal curve, right? You'll go -3, -2, -1, 0, 1, 2, 3 for the Z scores. Any questions on where we got those values from? All right. So now I'll do this one with you. It says find the area to the left of 60.5. So first we have to find the Z score. So we're going to do Z equals 60.5 minus 84.6 divided by 19.1. Okay, so everybody do that on your calculator. Let's make sure everybody's calculator works right. Get that answer ready in the chat just to that part. So you just had to do 60.5 minus 84.6, and you're going to divide it by 19.1. And we can just go to 2 decimal places. Let's just go to 2 decimal places, okay? Okay, are you ready? You got it on your calculator? Okay, let's put it in the chat. 3, 2, 1, go. There we go, nice. I just want to make sure our calculators are working. Okay. So Jinde, it looks like you just had your decimal point in the wrong place. There you go, perfect, excellent. Okay, so -1.26. So our Z score is -1.26, but that doesn't answer the question yet, right? To find the answer to our question, we have to go to the z table. So I'm going to scroll back up. Remember that number, negative 1.26. Remember, the negative is just telling us it's below the mean instead of above the mean. Okay, that's all the negative is telling us. So I'm going to go up to this z table. And I don't have a 1.26. So what value am I going to look at for my z-score?
1.3.
Very nice. But I'm going to look at negative 1.3, right? Do you see that negative 1.3? Make sure you look at the correct one. Okay. So negative 1.3, and it's the area to the left, is that value 0.0968. 0.0968. So now I'm going to go back here and I'm going to say, okay, 0.0968. And let's look at what that would look like on our picture. So we're shading things. So a z-score of negative 1.26 would be about here, right? Between -1 and -2. And look at my number, that makes sense. This is 65.5. We should be less than that. We should be at 60.5 because that was our X value, okay? And so when we're shading, the area to the left is right here. And so that area to the left is 0.0968 or about 9.5%, right? But if it wants the exact value, that's the value you give. Okay, so we did the shading on the region. So that's what you want to do. Now you're going to do B, C, D, and E. Calculate all 4 of those. I'm just going to let you work in here for about 5 minutes. When you're done, you can chat me privately if you want, right? Each of your answers so I can check them. If you have questions, you guys are doing a great job privately chatting me if you have questions or answers. So go for it. You guys want me to put up the Z table so you can see it? Okay. I put it in the chat before so you could pull it up, but I know you're probably looking at the worksheet, so I'll just move the screen to that, okay? Okay, how far have you guys gotten? I know you're not done. Did you get the second one finished? So part B? Malachi did. Did you get C done? You get C done? Good. Did you get D done? Okay, so the last one might be a little hard. Did anyone get E done? Okay, a couple of you did. Let's look at the answers and see if we can make sense of them, okay? I know some of you still want the Z table. Remember, you can have your own Z table. I'll put it in the chat again. So if you're doing your homework or whatever, you can have access to the Z table.
Will we need the Z table on the test next week?
Somebody answer, Jende.
It'll be on the test. You'll have one on there, right?
Yep, you'll have one in the question. You'll be able to see it. All right, let me go to these answers. So did you notice part B was the same as part A, except for you just had to do 1 minus that? How many of you noticed that? Okay, and I want to show you something on the Z table with that as well in just a second. We'll look at both of these, and then how many of you got C correct? 0.9893. Aaron did, Dom did, Yesenia did, excellent, Valerie did. And then notice that D, you just had to do, oh no, D was different. So D, did anyone get D right? Yay, a lot of the same people got D right. So I just want to show you something about A and B together on the table. So remember A, we looked at negative 1.26. So we looked at this -3 right here. We looked at this value right here. Is that what we looked at? Did I dream that? Okay, and then if you go over here, look at the positive value. Do you see how the positive value is the answer to part B? I mean, part B. Do you guys see that? So some of you might notice that connection. That might be hard for others of you. So it's just an interesting thing to note. Now, the last one was the hardest. This last one was the hardest. You had to find the area between 80 and 90. So first you had to find a z-score for 80, then you had to find a z-score for 90, and then I looked on the table and found those answers. And then what did I do with those two values? What did I do with that 0.4013 and that 0.6179? Can anyone tell? This is where drawing on the picture is very helpful. So notice I have a z value of negative 0.24, which would be right here, right? Very close to this mean. I'm just making sure I have enough space there. And then the other one is a positive 0.28. So it's going to be just to the right of the mean. Now, when I look up on the table and I get that value of 0.4013, that's all of this area right here. When I look up on the table and I get 0.6179, I'm getting all of this area right here. Notice how I have it double shaded there. Notice how this part right here has both the shading. So if I want to find this part in the middle, in between them, I will take this 0.6179 and subtract off 0.4013, and that will give me this value of 0.2166. So because if I have the area to the left of this and the area to the left of this, but I want the difference between them, I'm going to subtract them. So that's the most complicated part of this. It gets complicated when we try to find the area in between. But if you shade, it might help you. Okay. All right. So we didn't talk about our Thunderbird Thursday, but I'll just briefly tell you what it was, and it'll be on the slide. There's a civic engagement. If you're interested in volunteering with We Care Wednesdays, you can. There's a little course you can take about civic engagement. There's also a women's empowerment event that's on March 8th from 5 to 6:30. The president of our college is going to be there, as well as a lot of panelists. So if you want to check that out, that would be a great thing to check out. Let's talk about your homework. You have more S5 practice. It said it was due last night, but I moved it to tonight because that's what I told you. So if you didn't finish that more S5 practice, it's due tonight. You should be able to access it now. You have to do your info on taking a proctored test. That's due Sunday night. You have a practice lockdown browser due Sunday night. You have more S6 practice due Monday night, but you can get that done in advance if you want as well. And then you have your statistics review. So you have a lot on your plate because you have a test on Wednesday, right? So don't get behind with those things. Now, that being said, I'm going to put your exit ticket in the chat. It shouldn't be too hard. It's just finding a z-score. but some of you got behind on your homework. Am I correct? Is there anyone who missed a mini lesson or a more practice in the statistics unit from S1 to S6? A couple of you did. Would you like me to open them back up so you could redo them? All right. So I'm not opening the readings back up. I'm just going to open the mini lessons and the practice ones. Okay. So I'll open them back up until Tuesday night. Okay. So all of S6, you might notice a change in the due date. If you already did it, don't worry about it, right? Just leave your score unless you want to improve it. But if you need to do some of those assignments, you just need to get them done before the test so you know how to do them on the test. All right, excellent. Have a great weekend. I will see you Monday. Email me if you have any questions.